Good morning, class. So, Unit 4, Lesson 6, Application of Exponentials. This is the last lesson for Unit 4, Exponentials. So, before we go through these word problems, I want to show you a visual of what's going on. So, right now we're in the middle of COVID-19, and I grabbed these images from the above person on Twitter, and this represents the exponential growth of the COVID-19 cases, but notice that it is plateauing at a certain horizontal asymptote, right? And so that's like a real life, problem that we're going through right now. Meanwhile, these are more typical graphs that we have. So we have a linear pattern for the TikTok downloads, whereas for Instagram, it was an exponential growth from 2014 to 2018. In terms of a smartphone units sold from 2008 to 2012, it was relatively an exponential growth. And notice that the horizontal asymptote is at y equals 0. These are the types of problems that we'll deal with, and notice that it has a horizontal asymptote of y equals 0. So in this case, we have an exponential decay of carbon 14, and the 14 just means the mass of carbon, and this is for an isotope, because otherwise carbon usually has a mass of 12. So what this means is that it's usually going to start off with 100%, and over time, depending on the number of years, you're going to have a decay of carbon over time, and at the half-life, which means when is it going to be at 50% compared to its original? Well, the half-life of carbon is at 5,000 and something according to this graph. So that's how we interpret this kind of exponential decay graph. So moving on to our lesson itself, what we're noticing is that we're going to be dealing with real-life word problems where the horizontal asymptote is equal to y equals 0. And so that's why we dismiss the c, because c is just equal to 0, so we don't have to write it anymore, right? For these kind of word problems. So we still need to include one other part because we are dealing with word problems. And that is P. And what P is that it is a period of growth or decay. So how long does it take for that substance to get to its half-life? Or, for example, we could be dealing with an exponential growth, like how long does it take for the fruit fly population to double? And if that number is 200, that it doubles 200 for every 5 days, well, the period that it took to grow that long is 5 days. Okay, so meanwhile, we want to identify what each of the variable means. So we'll start off with the y. The y is the final amount. That is a dependent variable. Meanwhile, the x is the independent variable, and it's usually dealing with time. Just a reminder, the independent variable is what is changing. So depending on my time, my amount's going to change, and that is therefore my dependent variable. So depending on my independent variable, my dependent is going to change. And meanwhile, we have the a, the initial amount. We have next the A, the initial amount. So how much amount did I start off with? Well, my carbon might start off at 100%. So sometimes we deal with it as a percentage, or maybe grams, like 500 grams. That's what my sample starts off with. The B is the growth or decay factor, and that's different from what a rate is. So growth decay factor, we're going to compare what that is, factor versus a rate, more carefully in question 3. For question 2, it says to summarize how to find the B in the equation. So what the B is that if you are told that in words that it's doubling, that's suggesting that B is equal to 2. You're doubling that amount, so you're going from 1 to 2. Meanwhile, if the words are saying half-life, then my B is going to equal to a half. Because remember, when if I'm doubling the amount, that means that it's an exponential growth. Therefore, it's a number higher than 1. If it's a half-life, that means that it's an exponential decay. And so how much is it going down by? Well, it's going down by a factor of a half. And so my B is equal to a half. So that is dealing with the B, which is now different from the rate. In terms of a rate is when you're dealing with a percent increase or percent decrease. Like how much amount am I actually going up by? So for the doubling case, I'm going up by a rate of 1. And therefore, I have 1 plus 1, that is equal to 2. If I have a half-life, well, my rate is 0.5 because I'm going down by 0.5. And so in terms of an equation, it's going to look like this. So it's B equals 1 plus R for the percent increase, B equals 1 minus R for percent decrease. And notice that I'm using decimals and not percentage when doing this. So if I have R equals, let's say, 0.02, then I'm going to have the B value of 1.02. And so therefore, my growth factor will be 1.02, whereas my rate will be 0.02. Now let's take a look at question 3. So that 1.32, that the base is gonna be my growth factor or my decay factor. Okay, so I'm just gonna write that B is equal to 1.32. And how do I know whether it's a growth or a decay? Well, that B value is larger than 1. Therefore, it is a growth. Meanwhile, I have the rate. How do I find the rate? Well, we had that little equation from question 2, which is since B is equal to 1 plus R, and I'm simply going to sub in B is equal to 1.32 to try to find out what my R is. So B is 1.32. I'm going to sub that into that above equation, and I get the following. And so I'm going to be able to solve for R by moving that 1 over, and I'm going to get R is equal to 0.32. And based on that, I can write my conclusion, which is going to be, therefore, it is a growth factor when B is larger than 1, whereas you have the R, and R is a rate that it is going up or down by. So question 4, assign variables and set up the models for the following word problems. The value of the $250,000 cottage increases by 0.1% every 3 weeks. So I'm trying to identify each part. So the 250,000, that's the original amount. So I'm going to write A for that. Meanwhile, for the 0.1%, that is suggesting that that is related to my rate. So I'm going to write rate is equal to, but instead of me writing 0.01, I need to make sure I'm writing it in terms of decimals. So I'm going to use those arrows to bring it left 2 times. And so my rate is going to be 0.001. Meanwhile, it says every 3 weeks that that's how it's going to be increased by. That means that is the P. P is equal to 3, and we're talking about everything in weeks. So I'm going to start writing what my equation is. So I have y equals, see my A value, right, which is 250,000. My B value. Okay, so I need to figure out my B value on the side. Because I wrote R is equal to 0.001, my B value is going to be, well, it's increasing. So I'm going to do 1 plus 0.001. And that adds up to 1.001. So that is my base. Meanwhile, I have my X, and my period is 3. So that is how long it's going to take for my money to grow by that much. And so X is in terms of weeks. Meanwhile, the Y is dealing with the value of the cottage. Okay, question B, the 40 grams of radioactive matter within a mass. Question B, the 40 grams of radioactive matter within a mass decays at 2% every 30 seconds. The 40 grams, that right away is my A value. So A is equal to 40. It says mass decays at 2%, and so that means it's a decay. So interpreting that, I have my R value up. Again, moving that twice over, and I get R is equal to 0.02. So therefore, with my little equation, well, it's a decay, so I'm going to do B is equal to 1 minus 0.02. Therefore, B is equal to 0.98. Meanwhile, I have every 30 seconds, so that means my P, the period that it takes for things to happen, is 30 seconds. And so let's write down the equation. So we have y equals 40, which is the A value. My B value is 0.98. We know it's a decay. And meanwhile, we'll have x divided by 30 to represent that it is happening every 30 seconds. And so this is the version if this was if the x was in seconds, and the y will remain with grams. But sometimes it might be useful to be able to convert from one form to another. So what I mean is that, well, if I'm talking about things in seconds, what if I want to convert it so that we're talking about minutes? How are you going to do that? Well, I know that there are 0.5 minutes in 30 seconds. Like half a minute is 30 seconds, right? And so my new equation would be y equals 40, bracket 0.9. None of that changes, but I'm going to now have x divided by 0.5, where x is going to be in minutes. So just to clarify a little, x divided by 0.5 is equal to x divided by a half. And so that is equal to x times 2, or 2 times x. So I'm noticing that that might be a bad format, because I don't usually want a decimal over a fraction, like fraction over a fraction. And so this might be a way to tweak it up like so. Question C, we have the 200 fruit fly population that doubles every 5 days. So that means I start off with 200 as initial population. It doubles. That word double suggests that my B value is equal to 2. Next, every 5 days, that means my P is equal to 5. I'm going to put that all together, and I get Y is equal to 200, the initial value, and it doubles, so we're going to put a 2 there for the base. We're going to put an X divided by 5. So what does that each represent, the variables represent? Well, X will be in terms of days, and Y will be dealing with population. Question 5, assign variables and set up the models for the following word problems and solve the question. 5a, a certain strain of yeast cells doubles under certain conditions every 20 minutes. If there were 350 initially, how many will there be in 3 hours? So for question 5, what the difference is, sometimes they're telling you the x and y, and you're trying to solve for that missing variable. So it's not necessarily setting up the equation. You are setting up your equation and maybe solving depending on what the question is asking for. So for 5a, we have the word double. That means my B is going to be equal to 2 right away. And it says every 20 minutes, that means my P is equal to 20. If there are 350 initially, that means my A is 350 because that's my population initially. How many will there be in 3 hours? How many will there be in 3 hours? Well, they're telling me the X value then, and so X is equal to 3. And what are they asking me? Well, they're asking me how many. So that means they're asking me for Y. Okay, this is where we need to be careful. Notice how x is equals 3 is in terms of hours right now, and p equals 20 is in terms of minutes. We want to be careful before we start plugging everything in, because otherwise it's not going to make sense. So what I'm going to say is, well, if I'm dealing with 3 hours, I'm going to convert that to minutes, and I will get 180 minutes. I'm going to make sure I consider that before I plug things in. And so first, I'm going to write down the equation. So it's y is equal to a, which is 350. My base is 2 because it's doubling. I'm going to leave the x as is because I want to set up my equation first. And I have my p value of 20. And because my p value was in terms of minutes, my x will also be in terms of minutes. And meanwhile, the y will be the population. Now I'm ready to start plugging things in to try to solve. So I'm going to sub x is equal to 180 and solve for y. We get y is equal to 350, bracket 2, 180 divided by 20. We get y is equal to 350, 2 to the exponent 9. y is equal to, so remember on the calculator, I'm going to do 2 to the exponent, this little umbrella button, 2 to the exponent 9, I get 512. I'm going to multiply that by 350, and I get 179,200. And you always have to write a therefore statement for word problems, and so I'm going to get, there will be 179,200 cells in 3 hours. So question B, how long will it take for 1 gram sample of polonium-210 to lose 3/4 of its radioactivity if its half-life is 140 days? So let's interpret each part. So that 1 gram, that is A equals 1. That is my initial amount. Next, I have lose 3/4. I have to interpret that later, but basically I start off with 1, but I'm going to lose 1/4. So that means I'm going to have 1/4 at the end of this. Okay, I'm going to go back to that after. So meanwhile, the half-life, that part, this means that B is equal to 1/2. The 140 days means that my P is equal to 140 and my units are in terms of days. So in this case, I'm starting off with 1 gram, losing that 3/4, and so that's why I'm left with y equals 1/4 grams or 0.25 grams. Because I have y equals 1/4, that means out of all the things, all the variables, I am really looking for the x. And why do I know that I'm looking for the x? Is because it says how long will it take. That's suggesting that I'm looking for the x. Okay, so at this point, I'm going to start writing down my original equation with what I have. So I usually don't touch the x and y at first. So I have y equals, my initial amount is 1. That is how much I'm starting off with. The half-life, B is equal to 1/2. And then the x, well, x is going to remain as an x, and then the P is 140. And because my P was in terms of days, my x is also going to be in terms of days, and my y is going to be grams of this sample. While it might be very tempting to finish here, because it looks like the equation's set, we need to find the x. So I'm going to sub y equals 1/4, and you need to find the x. So I have 1/4 is equal to, I'm going to neglect the 1 because that's just not really actually doing anything. Put the 1/2 and write the exponent like so. So remember, there are 3 methods of trying to solve for this in our grade 11 course. One was to use BEDMAS backwards. Second method was to do the matching the base method. And 3 was trial and error. With this particular question, I'm noticing that I have 1/4 on the one side and I have 1/2 on the other side. And I know that I could tweak it so that the bases are matched. Okay, I'm going to write 1/4 as 1/2, and if I put that whole thing to the exponent of 2, I will be able to match the bases. So I'll put 1/2 x over 140, and remember, if you have matched the base, you can now drop the base. And just let the exponents equal, so it's 2 equals x over 140. And that is simple algebraic work, and I can now just get finally the x by itself, and x is equal to 280. And since it's a word problem, we have to go back to what we did, and basically it took 280 days for this polonium-210 to lose 3/4 of its radioactivity after 140 days. So for a biology experiment, the number of cells present is 1,000. After 4 hours, the count is estimated to be 256,000. What is the doubling period of the cells? So the 1,000, what does that mean? Well, that is my original initial amount. And then after 4 hours, that means it has been 4 hours since. The count is estimated to be 256,000. So this is dealing with a specific case. That means my y is equal to 256,000. And what is a doubling period? So they're asking me to, well, they're giving me 2 information by that. It's asking me the P, and it's telling me my B is equal to 2. let's set up the equation. So we have y equals initial amount is 1,000. My b value is 2. I'm going to leave again x as blank, and I don't know what my p is. That's my initial setup of the equation. At this point, I'm going to sub a coordinate, sub x equals 4, and y is equal to 256,000, and I'm going to solve for p. So 256,000 equals 1,000 bracket 2, 4 divided by p. Now you're going to try to do BEDMAS backwards to try to find p. So first I'm going to divide both sides by 1,000, and I'm going to get on the left side 256 because my zeros will cancel out on the top and bottom, and I get 2 to the exponent 4 over p. Okay, there's a couple of ways to do this, but I'm noticing that 256, and in my case, you could have done prime factorization for 256. I did a guess and check because 256 seemed like a reasonable number, and 2 to the exponent 8, in this case, perfectly equals to 256. So you write that number as a base of 2, and I'm using that matching the base method. Side note, make sure your 8 is small enough so it looks like an exponent. So I get, well, my bases are dropped, so 8 is equal to 4 divided by p. I can get p by itself by doing cross multiply. And I get, well, 8p is equal to 4. I have one more step. P is equal to 1 over 2. Keep in mind, this is a word problem, so I would like you to obviously work with exact numbers where possible, but for a word problem, it is useful to write the decimal version. So interpreting this, that's basically 0.5 hours. And that is equivalent to also 30 minutes. So just being flexible with writing down your answer in different units is a good practice. And so the final answer is going to be, therefore, it will double every 30 minutes. Or you could have said, therefore, it will double every 0.5 hours. So in general, what you say and how you say it in terms of what units is flexible, unless the question says, please tell me the time it took in minutes, time it took in seconds, time it took in hours. So if they are specific, yes, you do need to indicate in the particular unit. Okay, so moving on to the second page, what I want to advise you is that tip is to make sure that the time units line up. Example for period and time. So there were, we had to do that previously for this case. Otherwise, all of our work would have messed up. So we have to make sure that the period time and the time units all line up. So question 6. Question 6a says a drug's effectiveness decreases as time passes. Each hour, the 250 milligram drug is only 95% effective as a previous hour. How effective is a drug after 150 minutes? So let's interpret everything. So 250 milligram is the initial amount of the drug. It says also that each hour this is being affected. The effectiveness of the drug is being affected depending on the amount of hours. So I'm going to say that the P is equal to 1 hour, or we could also say in terms of 60 minutes. So either or depending on where my units align. Next, I have that it is 95% effective. That is telling you directly your decay factor, and it's 0.95 exactly. Basically, your R in this case is 5% or 0.05. And so you get B by doing 1 minus 0.05, and you have B that is equal to 0.95 exactly. So the how effective is this drug after 150 minutes, they're telling you a specific scenario. That means that X is equal to 150 minutes. Notice that with my units, remember how I wrote 2 different versions? I want to make sure I'm using the correct minute. So I'm going to use the minutes rather than a mix of hour and minute, because otherwise it will mess everything up. So I have Y is equal to, initial amount is 250, bracket 0.95, X divided by P, which is 60, and X is in terms of minutes, Y is in terms of amount of drug. Am I done? No, I'm not. I have to sub X is equal to 150 to find my answer. And so Y is equal to 250, bracket 0.95, 150 divided by 60. And on the calculator, you'll do 0.95 to the exponent 150 over 60, and then you're going to times that by 250. Make sure that you're getting these numbers on your calculator, because you might be, again, inputting your numbers incorrectly, which is going to affect what you get on your assessment, right? And so you should be getting the number 219.9 milligram, and then our therefore statement is, therefore, after 150 minutes, 219.9 milligram of the drug is effective.